Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Denya Hakim bin Abdul Samad. So today I want to present to you about our assignment. So we study about total mortality in Johor. We are from group 4B. So for the introduction, between 2010 and 2019, the number of deaths in Johor slowly increased. This isn't too surprising because as the population grow, people birth, more people get older, and we see death over time. So from the data that we study, as you can see here, in 2010 to 2019 it slowly increased. This data was obtained from the government website, which is OpenDOSM. The data given is about the total death in Johor in years. So it actually have many range of years, but we take 2010 to 2019. So we use this information to support our assignment, and since year is a continuous and independent variable, we label it as exists, while death in Johor is a dependent variable, and therefore we label it as y exists.
The next one is quadratic model. So from the data, we can take x represent the year, and then y represent the total mortality instead of Johor. And then we put the data xy into the quadratic equation, which is a plus bx plus cx square. Then we take the coefficient number and put it into the coefficient matrix, which is as equal to b. And then after that, and then from the coefficient matrix, we change it into augmented matrix. So after that, we can reduce the augmented matrix until we get leading one to get a row echelon form, which is REF, and then we can know to verify the consistency of the matrix to know the solution which is inconsistent or consistent. We use a elementary row operation to reduce the matrix until we get a REF. So we reduce it until we get leading one in the front, and then after that we can see that we have a contradiction, so the solution will be inconsistent. Okay, so for the next one is normal system equation, which is A transpose times with A times with S equal to A transpose times with B. So we calculate each by each. So the first one, we calculate the A transpose times with A. So we got the answer, we got 3 by 3 matrix. Okay, after that we calculate for the determinant A transpose times with A. So with the determinant, we can determine whether the solution has unit solution or many solution. So since the determinant of A transpose times with A is not equal to 0, so the solution has a unit solution. So we can proceed to the next step. So we calculate first for the A transpose multiply with B, and then we got a matrix the size of 3 by 1. And then from the data that we calculate previous, we can put it into the normal system equation to find the least square solution. So we put it into the equation side by side, and then we change it into the augmented matrix. From the coefficient matrix, we change it into the augmented matrix. So we can reduce it until we get RREF, which is reduced row echelon form, to get the value of the A, B, and C. So from the value A, B, and C, we can put it into the quadratic equation, which is A plus BX plus CX square. So we reduce it until we get the equation, and then we put it into the quadratic equation, and we get the least square. So next one, we need to calculate an error vector and magnitude of error vector. So the formula to calculate an error vector is B minus A times mu X. So we take the method of B, and then we minus A times with X, and then we need to calculate first A times with X first, and then we can just B take the matrix B and then minus with the answer that we got from A times with S, and then we get the error vector and each value. So after that we calculate the magnitude of this error vector. So we take each by take the value of each error vector and then we square it and then sum it, and then we just square root the answer, and then we got an answer which is 600.14.
Assalamualaikum and good afternoon. Today we will analyze the mortality rate trend in Johor over 10-year period using mathematical modeling technique. We will explore how lineage algebra help us understand pattern in public health data and make informed observation about mortality trends. Let's start with the raw data from 2010 to 2018. Johor recorded increasing deaths count from 90,060 to 21,799, with mortality rate rising 4.8 to 5.8 per 1,000 people. Our goal is to model this trend mathematically to understand its underlying structure. To model this, we define three vectors. F represent the years 10 to 90, standing for 2010 to 2019. Second is G. G is the square term of years for quadratic modeling, and the lastly is H. H contains the actually death count. This setup allows us to explore whether mortality follows a linear or quadratic trends. Second, constructing the model matrix J. We use a least square approach to fit a quadratic model. The matrix J contains a column of first constant term, second a column for the years for linear terms, and a column for square years for quadratic term. This structure helps us find the best fitting curve for the data. Third, solving the normal equation. To solve for the coefficient, we compute J transpose J, second J transpose H, projection of data onto the model space, and lastly raw rejection give us the coefficient for the best fit quadratic equation. Determinant 43,516 confirms a unique solution is exists. Model visualization. Plotting the model against the data, we see the quadratic curve fits the upward trend. The acceleration suggests future mortality rates may rise faster unless underlying factor change. The final quadratic model. Our derivatives model is the constant term 12,702 represent baseline mortality. Second, the linear coefficient 156.2 shows yearly increase. The quadratic coefficient 70.4 indicates acceleration in the mortality. This suggests mortality is not just increasing linear but acceleration over the time. Here's the arrow vector showing deviation between predicted and actual death. The magnitude 1,897 quantifies total error, while not negligible. The quadratic trend still capture the overall patterns well. So I'm gonna explain you about the explanation of finding. First of all, data visualization. The dataset consists of the mortality in the state of Johor by period of 10 years. In Maple, we define the dataset as two arrays, one for F as the years are represented by their respective coefficient, and one for G as total mortality by years. Second, using the function point plot, the code will generate a scatter plot showing the mortality in the state of Johor. Error calculation. Here we compute the predict value and subtract this from the observed values, which is H, to find the error vector. The magnitude of the error vector is then calculated using the normal error vector 2. Next, linear approximation. In this section, we first solve the augmented matrix to RREF form to prove that the system is inconsistent by using the function reduced row echelon form. Therefore, we use the normal equation A transpose AX equal to A transpose H to solve for the best fitting coefficient F. We also find the determinant of A transpose to check whether the system has infinitely many solutions or has a unique solution using the function determinant A transpose. A function plot is then used to illustrate the quadratic graph based on the resulting vector which contains the coefficient for the model. To conclude, after doing manual and maple calculation, we found the best fit equation to be y equal to 12701.75 plus 156.05x plus 17.41x squared. This means the connection between the variable is not constant. The pattern is curved. It is not straight. We also calculate the error tau and its magnitude to see how accurate our model was. We got the magnitude was about 600.14, which is high, showing that the model does not fit the observed data well. To sum up, using a quadratic model help us better understand the pattern. That's all from us. Thank you.